Number 27. The pressure of an ideal gas varies directly with the temperature and inversely with the volume. The values of the initial state were 2 atm, 6 liters, and 300 Kelvin. What will the pressure be in the final state if the volume is reduced to 2 liters and the temperature is increased to 500 Kelvin? So, you've probably seen direct variation and inverse variation used kind of just by themselves, but this is a case where they're used in the same context. So, as a refresher, direct variation basically says if you take your y's and you divide by your x's, or you take your outputs, divide by your inputs, that's going to be some constant, right? No matter what y or x you pick on that line, you're always going to get the same constant. Well, inverse variation is kind of the opposite of that. It's saying that if you take any two x and y on your it's not a line anymore, but on your function or your equation, the product of those two will always end up being a constant. Okay? But now we have a little bit of a variation of that. A little bit of a combination. So we see the pressure of an ideal gas, it varies directly with the temperature. So off the bat, what that tells me, if I'm ignoring everything else, the pressure of the gas varies directly with the temperature. That tells me that the pressure divided by the temperature is going to be some constant. And then it tells us the gas also varies inversely with the volume. So that is just multiplying by the volume. If it varies inversely, the product of them is going to give you that constant. And also, for those of you that have taken chemistry, you might recognize this as just a variation of the ideal gas law, right? So the number of moles and the ideal gas constant, well, those are going to be constant. And so you can see, well, if I combine these two into just one constant K, then K would equal PV over T. If you haven't taken chemistry, don't worry about that. But maybe that, for those of you that have taken chemistry, maybe that gives you the necessary background. So whatever this is always going to be equal to a constant. So let's figure out what that constant is actually equal to. So in the first state, in the initial state, it's 2 atm, 6 liters, and 300 Kelvin. So our pressure is 2 atm, and then it's inversely proportional to the volume. So I multiply by the volume, which is 6 liters. And then it's directly proportional to the temperature, which is 300 Kelvin. So I'll divide by 300 Kelvin. And so K is just equal to 12 over 300, which is just 0.04. Now it wants to know what will the pressure be in the final state. So now we're looking for the pressure. What will the pressure be in the final state if the volume is reduced to 2 liters and the temperature is increased to 500 Kelvin? So we use the same equation because no matter what PV and T are, they're always going to equal this constant, right? As long as you're in this system. So 0.04 will always be PV over T. So we're solving for the pressure, and we have the volume. The new volume is 2 liters, and our new temperature, which we're dividing by, is 500 Kelvin. So now we just solve this equation. 0.04 equals P times 2 over 500. So P will just be 0.04 times 500, and then divide that by 2. So let's see, 0.04 divided by 2, that's 0.02, which you can think of that as like 2/100ths. Well, 1/100th of 500 is 5 times 2. So that gives you 10 atm. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe, and I'll see you next time.